So today we are going to be talking about the never-ending paper from Google on on this continuous delivery, continuous integration, and what they have dubbed continuous training. This is the fourth installment of our review of this paper, and it is a way for us to dive deeper into the different automations and how automated should you get and the maturity levels of different companies. What have we talked about so far in these last three? I can't even remember, David.
Yeah, we've talked about a lot. We going back to the very beginning, we tried to break down some of the assumptions and the presuppositions that the paper was kind of bringing into it. So things around the need to automate everything. Their own definition of MLOps. They talked about the distinction between MLOps and DevOps, talked about the data science workflow, and then we took a closer look at these different data science workflows through the lens, or these three different levels, or today the last level, of like the basic maturity level where things are mostly manual, the first maturity level where things are now becoming, second one, things are now becoming more automated. And then today we're going to talk about this last one where what they view as the entire pipeline is automated. So this is kind of the final installment of the series today.
All right, let's get into it. But first, roll the intro.
Lights, camera, action.
Getting seen. Hill, could you get me some coffee?
There's no more coffee.
No coffee? No coffee? Ah! If I can't take my coffee break, my coffee break, my coffee break. If I can't take my coffee break, something within me dies. Something within me dies. Yes, something within me dies. And scene.
And we're back. I hope you enjoyed that cheesy intro. It's not every day or every video that you get the pleasure of seeing that. We just lace it in there every once in a while when we feel bored. So now, what do we got here, man? We're on level 2, which is really level 3. Google really wants to make it confusing for us because there is a level 0, there's a 1.
It's very programmer-like because most programmers are comfortable with 0 indexing, so you start at 0. Which took me actually when I first started programming, that was not, I didn't quite understand why, but yeah, I guess this is how it goes.
There it is, man. So
let's get into it. So one of the things that they're talking about here in this last section is that they believe that for a rapid and reliable update of not just one part, but the entire pipeline in production, you need a robust system to enable CI and CD, which is continuous integration and continuous delivery. And automating that lets your data scientists rapidly explore and try out new ideas, experiment with new things. And this could happen at many stages of the pipeline. So it could happen at the data level where you're playing around with new features and new combination of those features. So hopefully you have a feature store to enable some of that and make some of that a little bit easier. You could be trying different model architectures, different parameters, hyperparameters. So you're at this stage of still experimenting. But if you're able to quickly iterate, on those things, it makes it a lot easier to get those ideas to production. And they think that what you could do is you could implement these ideas by automatically building everything, automatically testing everything, and then automatically deploying not just a prediction service. So again, we've been kind of most models of this show that you're going to put into production a single prediction service. So like some little service, an HTTP endpoint that exposes those predictions or make those predictions available if you make like a GET request or post to it, typically a post. And if you're following this paradigm, you're not just pushing that into production. You're now actually pushing the entire pipeline. So the beginning stages of that pipeline that take the raw data, process the data, generate the features, train the model, maybe even run a hyperparameter search, and then launch your deployment service. So it's all of that they're actually pushing into prod.
Let me share my screen real fast because we have the different diagrams right here. This is level 1, right?
Yeah, let's zoom in a little bit, so that
All
people
right.
could get a sense
Yeah,
of
let's get it
where we're
better.
going. And by the way, something that me and Demetrius were talking about is that we actually really liked going through this paper because we learned a lot. We wanted to see how all of these pieces fit in together. So I would encourage listeners, if you have other articles or other papers that really give you this systematic overview of the different pieces and how they play together, I'd really love to read more of things like more of stuff like this. So please send that to us. But this is the manual process. Again, we're not going to go too much go back into this, but they characterize it as being very manual. You're only launching your prediction service, and you're typically only launching that into your production environment. You're not launching any of the training pipelines or any of that in your prod environment. So there's a big disconnect between your experimental and your production environment here. Go down
and then we go into level 1.
Yeah, level 1, they turn it up a notch by keeping a link between the experimental and the production environment, which is really good. You're now not just deploying a prediction service, but now you're deploying a pipeline. So you have that. They've introduced some new components, such as a feature store, a metadata store, so something that's keeping track of all the experiments that are running in the system.
The model registry, I think.
Yeah,
Did they
model
have that in the first
registry.
one?
No.
Oh, yeah, they
actually,
do. Yeah,
they do. Yeah, so model registry. And then, you're again, it's like the same sort of flow, but now you're trying to automate a lot of these steps. So you've introduced some things that enable continuous training. And the idea behind that, like we talked about, is that if some new data is available or some changes is made in the world, you should be able to reproduce a model that can then be directly deployed. So you want to be able to rerun everything from scratch and then produce a new service versus kind of having to ad hoc string together those different pieces that put that model into production. So it's a little bit easier to actually adapt if you're deploying not just a prediction service, but a pipeline, so that we could just run everything all over again, create a new prediction service at the end of that.
And to what we're talking about today.
Yeah. Now
this
today,
one,
this is
for me, it wasn't such a big jump. Like you look at this jump and you go, oh, from 0 to 1 is like, damn, there's a lot happening that's different on this one because you're deploying this pipeline and now you've all of a sudden got all this happening in the production or staging pre-production environment. And then you have, but from here, so from 1 to 2, for me, it didn't feel like, oh, this is so different, right? It's just like tweaking and polishing in my mind.
Yeah, and also that you notice they've added a couple of new components like packages. So these packages is something new that's here. So now and this is like, again, with Kubeflow in mind, where you can compile a pipeline. And what that means is that you take some Python file and then you produce, I think it's like a tar or a .gz file, but it's a compressed format of that pipeline. And maybe you have even other things like other Python packages, other utility packages. So this is the stage where we prepare all those things. And maybe in a more manual sort of environment, there's no need for some of those things. You would add these things that get to add, not add more complexity, but maybe to like you start creating new things to take care of one thing. So this does that, this does that. So maybe that's what's happening here. Personally, I didn't really. Packages is something that I haven't really seen talked about too much elsewhere. It could be that to me seems like a super general thing, like what type of, and it depends on what type of languages you're using, right? Like how, the language works. But let's get into it because it's not so much about what's so different about it. It's like kind of what's more mature about this from the perspective of Google with respect to automation. So there's a couple differences here. Notice how now you're doing some more model analysis. You still have some of the major components of that first level, right? But now you have this other aspect that now you're putting in some packages. So let's get into it. Now, there's some not basic components, but there's some necessary components that this system design, I guess, requires. We're going to talk about some of them. Me and Demetrius are going to go back and forth. The first one is you need source control. So source control is, we kind of talked about this a lot actually, but it's when you can track and manage any changes to your code. And this is really important because you want to maintain a single source of truth. And what this does is enables you to collaborate, right? So you have not just one person working on this code, but lots of different people. And that supports all of this, because whether you're building packages or a pipeline, there needs to be one place where that exists for maybe a single model. And maybe you have like the type of use case where you have multiple models existing in like a single mono repo. But if that model is complicated enough, maybe it has its own little environment and has its own sets of packages. Nevertheless, you need to have some sort of source of truth. And then next we have some test and build services. So you need to enable this continuous delivery. You want to be able to continuously integrate that, and you want to be able to continuously test that. So if there is maybe Docker files that you need to build, right? You need to build some images. You want to be able to automatically do that. So one way that I do that is using GitLab. And if I make some code base to master, some change to master, it'll once I push that change into master, it'll automatically rebuild the images and maybe release a new tag if I want to. So it gives us a way to automate some of these steps that you could do them manually, but it's less error prone when you do them in an automated fashion. And then also if you have this, something like GitLab, a CI/CD pipeline, then you could, after you build your images, after you run all your tests, then you could automatically deploy your model into production. Now, what that could mean, it depends on how you deploy services. So if you have like a Kubernetes setup, maybe you have, maybe you're using something like GitOps, or maybe you're just doing kind of your own solo Helm deployments, or you're just doing, your own Kubernetes stuff. But the point is, there's lots of different ways that you could do this. But if you have some system to automate the building, the testing, and the deployment, it makes you a lot faster, right? You can iterate a lot quicker. How about you talk about some of these other ones, Dimitrios?
Well, I was just going to mention, like, we had touched on this in one of the first episodes, I think, is how this architecture and the way that they're looking at this is very much like skewed towards if you have Kubernetes and if you are looking at like in a Kubeflow fashion, right?
I think so, but I would also say that this could be generalized to something very different. So like, if you want, we know there's other orchestration tools or whatever, like, things like Flight, or we've heard about Metaflow that allows you to create a DAG, or Pachyderm. I'm sure there's lots of different pipelining tools that could fit in with this model. And let's say this is not even, maybe you're not dealing with a Kubernetes cluster. Maybe you have some sort of other cluster orchestrator. You're probably going to have different environments, right? You probably have like a experimental or dev environment. Maybe you have a stage and a prod environment. So I actually think that the only thing that really skews, or one of the biggest things that skews it towards this like Kubeflow sort of way of thinking, is around things like that. They mention some aspects of a pipeline as like, you should be able to compile it, or you should be able to run each component of a pipeline as like a container. I think there's other ways to go about doing that, but it seems to be that actually is pretty common to a lot of these other tools. Like at least from what I've seen, a lot of these other tools will allow you to run some container as like a step in a pipeline. Or maybe they do that for you, maybe you have to do that yourself. But I don't think that this just applies to Kubeflow. At least that's my take on this.
Okay, cool. Well, I mean, yeah. What do you want to talk about? You want to talk about the?
Let's keep going with what are these, like what is required to have this? So we talked about you need source control, test and build services. Let's talk about some of these other ones.
Feature store, maybe, or
even before that, even before that
last time.
Let's talk about some of the other ones, like a deployment service. Let's talk about the model registry. Let's talk about, and then we could get into the feature store and stuff like that.
And the model registry is one of those interesting ones, because I remember when we were talking with David Hershey from Determined AI, and he was mentioning how important it is. And I remember that when we would talk to people when I was at Dot Science, and we would talk to like fintech companies, and how big of a deal model registry was, so that you could go back and you could see, or even like at this moment, you can see how many models do I have in production, or what is going on out of all the models that I have right now, which ones are in production, which ones are in this stage, which ones are in that stage, so that if in case I ever got audited, I could easily say, okay, these are the models that are running. These are what's going on.
Yep. And you have metadata around that too, right? You're going to have things like what type of model it was, what parameters were used, what times were associated with that. When was it created? When was it trained, right? Maybe you'll have even like metrics associated with this. You can quickly see how this one is doing.
Yeah, exactly. You want to, so for the model registry, and then like, I remember at Dot Science, one of the big things that we were doing was like the data that it was trained on, that kind of metadata that you could just be able to go back. And the whole idea here is that you never get in that position where you're like, oh, how did I come up with this model?
Yeah. You should never be in that position because it's sometimes it can be really hard to get back to that stage, right? Depending on like how convoluted the code is or how complicated the use case is, right?
Yeah. Well, and I mean, so like looking at this, it's like you deploy this pipeline, and this pipeline does all of this stuff, right? Like the data extraction, the data validation, data prep, which we talked about in the last episodes. And then from there, the model gets served, but it also gets put into the model registry.
Correct. Yeah.
And we saw like before in each one of these, in 0 and 1, you have a model registry, but it's a whole different way of looking at it. When you, so like you see it's still the same kind of thing that is happening in 1. Like you have the metadata store, you have the model registry, and then it gets served. And here it's just like, for me, there's this I guess there is a real emphasis.
And there's this pipeline's in production, so keep that in mind. That like this is, you see how they have like before in the earlier stages, you would only have maybe a pipeline to produce those trained models and push them to the model registry in only your experimental environment. But if you have a production system where you're getting production data and you need to be able to train models using not just your experimental pipelines, but also your production pipelines. I mean, obviously, they should be very closely related, if not the same. But yeah.
Sweet. So then moving on, I mean, we've got what we talked about, trained models they get served. Then here's something I think this is a little different than the way that they architect it here, the way that they look at it here between number 2 and number 1 is that, oh no, actually, my bad. It's the same.
Good.
I got a little bit confused there.
These pictures are very similar. Maybe instead of focusing on the pictures, we could keep going on what again the biggest difference is just like they're automating everything now. Again, it's not so much like a different architecture, but yeah. So they do have in the level 1 a feature store as well. This level, it does have a feature store, and just to highlight again for those who are listening. It's what I like to think of a feature store as an interface between the data and the models. So it's a way to it's like something that your model can pull from. You could do it in your offline environment, your online environment. You could do it for experimentation, for your production use cases. There's typically several layers to it. There's been some really good articles that have been put out about what a feature store is.
Yeah, actually,
I would encourage you to check them out.
We'll put one that just was plastered all over Slack from the folks at Tecton, because that was like a great definition of what you should look for in a feature store, what exactly it is, because I think there's not such a clear definition of it and what is needed. And then the other thing is like feature stores, man, you've been a few different coffee sessions we've had people talk about feature stores, like, oh, we're looking at that right now. So it seems like it's a pretty hot topic.
Yeah, it is. Personally, it would make my life a lot easier for certain things if I had, something like that, because it's such a crucial part of like the typical data science flow. Like features are everything. The data is what powers everything. If you could have, the model is such a small part, the training code, and that's like a cliche now because we all say that, but it really is. And because of that, I think that it only makes sense that there would be a lot of care and attention put into the features and the data. And now there's starting to be definitely more focus on that, as I think there should. And there's always going to be the phases, right, where one is more hot than the other. But in general, care for your data seems like it's always going to be relevant, always helpful.
Yeah.
But yeah, so
the other thing that I was just going to mention, yesterday we were talking with Satish, and he gave us a lot of great insights on, because like feature stores, they can serve it up, or they can give you like batch or real time, right, features. And one thing that was a great takeaway when we talked with Satish was him saying, like, be very mindful on what you need served up in real time and what you need batch, because you can end up spending a lot of money trying to architect something that you need real time, when really it's like, actually, that could have been batch.
Yes, that's a great point, because there's a lot of overhead in building, a real-time system or a streaming system, and unless that the business actually requires that, it just does. I don't really see why you would want to, deal with all of that complexity, because it's non-trivial. And there's you hear these war stories all the time about like the difficulty of deployment, standing up some of these tooling. And it's not easy. So I would.
One thing that I've heard, sorry to just harp on this feature store one,
but, not at all.
And I know you've told me it before, you're going to have to tell me it again, because I can't remember. And it always comes up in my mind because I associate it with like food and Uber Eats, but like the freshness of the features. Is it the freshness of the features or freshness of the data? I know there's the freshness of the data.
Both. I think both apply. So like you could have maybe one feature is generated from other features, and if those other features change, so say the distribution changes, then that other feature could be affected by that. Or it could be a data source. So maybe that data source is affected. Maybe it went stale, again, thinking about those different changing environments. And then you would need to get the latest data. So again, it's usually things that have a time component to it. So like, let's say prices for stocks or securities, their prices change all the time, right? Yesterday's prices are yesterday's prices. Today is going to have a whole new set of prices, and they constantly change. So if my model is predicting today's prices, I can't have yesterday's data. Maybe I guess that may be one way to do it, is that you have the ability to, your model can generalize to the next day for a day at a time. I feel like that sounds more reasonable and definitely doable. But maybe you also have a situation where you actually need to respond and train in real time, in this continuous training to respond to those changes. And if that's the case, then this idea of freshness maybe even becomes more prevalent, because you need to have the latest production data and your model trained on that latest production data. If not, then you get things like concept drift, which we've talked about in the past.
And so then it would be like the freshness of the features that are super important.
Yeah, but I would say features is just the data, So I even it's just a useful form of the data for the model, and the model could even have a freshness to it, a staleness, like we talked about. If it let's say needs to be updated frequently because of the specifics of the problem, then that model can go stale. But so can data, right? Yeah. The data can be, maybe the model is still working, still making valid predictions, but one of those features is no longer relevant because something changed. And that's not necessarily a bad thing. You just be mindful of like how time affects the different components of your system.
Nice. Well, yeah, man. Perfect. Now let's keep moving. What do we got next? I mean, we talked a bit about the metadata store.
Yeah.
This is just
I want to highlight what I think that, not what I think, what the paper highlights as what a metadata store should capture. So I think at a basic level, what ran. So if I'm looking at the system, I just want to know what's been going on, how many runs. If I want to click on a run and see more information about it, that sounds reasonable. So you want to highlight at the system level what went on. You could even go more granular and look at the specific jobs that ran, each of those steps, maybe look at the logs. So things like the start, end date, the execution environment, did it run in, what node did it run in if you're using the cloud, what parameters are passed in, pointers to artifacts that are produced, packages, trained models, data, and then things like metrics and performance. And I think this is actually a really important stage, and there's been a lot of love being put into this now on monitoring, and rightly so, because a lot of this stuff can be framed as just like engineering, right? But you got to look at what's going on with your model, and one of the best ways to do that is through metrics, right? You have to. That's like one way to see what your model is doing, and there's all sorts of things that you could do to make those metrics very specific to answer the questions that you wanted to answer, right? Like, if you're looking at a recommendation system, certain metrics are better at summarizing the entire recommendation list. Others give you a better sense of what's at the top of that list. So there's different ways to evaluate like your model, but that's more of a science, or like AI sort of a science type of thing. But notice how it's like good engineering enables you to do that. Like if I have the ability to capture all the metrics throughout my system, and if I'm recording that in some way, maybe I'm plotting it over time, I have a quick glance, at how things are doing. It's not perfect. You still oftentimes need to go inside and debug the model, introspect it, maybe use model interpretability tools like SHAP scores. So there's lots of things that you need to still do to understand what's going on. But metadata captures at a high level what's going on. It just makes it easier to reproduce experiments, rerun something, roll back to a previous version of something. And to be honest, this happens all the time.
So when people talk about explainability, would that be part of this metadata store?
I think it could. So like some tooling, then like KF Serving has integration with tools like Alibaba not Alibaba, sorry.
Alibaba.
Is it Alibaba?
I don't think so. That's
it sounds like that's a natural language tool or something like that. But they allow you to essentially like add another endpoint to that prediction service that allows you to add interpretability. So like it'll take like a sample of your predictions and then tell you something about your model. So I think that it could be part of the metadata because it's like, again, data about it's like meta data about the data that's happening inside. So yes, I think that could fit there as well. You could even include things around like the deployment metrics. So maybe this is monitoring and metadata are closely related, but they may actually be like, you may have metadata at different stages and monitoring is looking at like a high level of that, which is kind of what this picture is showing. Like you see the performance monitoring, like it's not really focused on just, it is focused on the prediction service, but you could have it take a look at a lot of other parts and be collecting metadata about that as well. So it could be as complicated as you want it to be.
So the idea here at like the big picture zooming out is that I push a model into production and I like forget about it, or what? Like I don't, because everything is automated. So if the model starts to not do what it says it does, then it automatically gets retrained.
If you have like automated triggers, so like that's the other part that we talked about, is that maybe also in this sort of architecture, you've enabled triggers that have maybe thresholds that say when you pass this, if you're not past this baseline score, retrain the model or get fresh data, whatever it is that needs to happen, or just rerun everything. Or it could be something like there's skew. So maybe you have outlier detection enabled, concept drift detection enabled, so it could look more detailed and see is the feature distribution changing over time. So it could be more involved like that, and that could be fully automated. But I don't think, honestly, there always needs to be some oversight. Like even if you have a perfectly automated system, like you could be automated in the wrong direction. Like, and I've done this myself, where like I've automated the shit out of everything. Like, oh, this is sweet, but like I'm doing something wrong. And that's why I think it's important to highlight that this is not just engineering. There's a lot of science here, and that makes this a lot more than just, I just need to let it go and run. Like, because you have this added element of complexity, you actually can't just leave it alone. It can't just run as like just its own thing. That's why, like, people talk about like AI and like taking over the world. This is a side note. I'm not convinced. I'm not convinced. Yeah, I think you always
not when you can not figure out how to put a regression model into production and get it automated on its own.
Yeah, I don't know. So even though this is like the fully automated system, as they say, everything is running, through the continuous delivery and all that stuff. I still think that you still need people to monitor it. Like they mentioned earlier, oftentimes in the monitoring stage, that's where the real data science occurs. um, that's where a lot of things may happen, and you actually need. I mean, it depends upon your use case. Like
Because
if
of
you
the
have like,
insights that you're getting, you mean? Like, so once it's out there and then you're getting
yeah,
all of this
yeah,
this
yeah, you're
data on how
learning.
it's
Yeah,
working.
exactly, man. Like I think we've talked about this before, but you actually really start learning when you push that into prod. You start learning about what the traffic is like, how your users are engaging with it, where your models is wrong or right. And I don't think that that's trivial.
Hmm.
Like that, people act like, oh, it's just out, I'm done. Like, no, at least that's never been my experience. Like
And well, it
I
seems
have
like
yet to, yeah.
that's why you have this whole. That's why I think it's smart how they separated the experimentation and dev test part, because it's like we said, you put it out and this can be running, and then you can just start getting those insights and like just one upping each time when you put a new model into production. So you have here, you learn from it, and then you push it back out, and then it can
Yeah,
do
yeah.
its
You see how
thing
they have
here.
that model analysis. So you're doing data analysis. There's a feedback loop, right? So you see how
Hmm.
it goes from performance to then data analysis, performance to data analysis, and this is where I
Yeah.
think why you need the data scientists there, because okay, I as an engineer, I'm like maybe this is not the case for everyone, but I care about the engineering. I care about the machine and that it's running smoothly. Those are my concerns, and I like look at it as like a black box. Like it's just some algorithm and some data, and it's complicated. I could go in and look into the details of it, but I'm me personally, I'm less concerned with that, and that's why someone who is actually who's built it, who's developed those features, who did all that research, they would be in the best position to understand when it goes wrong. Like that's why this whole idea of just give it to the DevOps team or the IT team or the deployment team to just deal with it. It to me it seems wrong. There shouldn't be such a disconnect between the real life deployments and the people who are developing it. And I don't know how to do it's challenging because you don't want to make them responsible for everything. But if the engineering is done right, I think that that monitoring really is just them doing what they normally do, learning from their environment, learning from their experiments, and getting feedback and using that to go do data analysis, using that to go do more model analysis, and then developing new ideas that they can, if the engineering is right, quickly feed that back into production. So it's like enabling this quick loop of something's going wrong. What the hell's going on? Let me go take a look.
Boom.
Let me go make some changes. Boom. But if it's automated, then there's less. And if the engineering is taken care of and if the abstractions are helpful, right? Someone who is less engineering savvy should be able to have all of that run smoothly, right? But again, it's the engineering that I think enables all of that to happen. But it's not just an engineering concern. You see what I'm? There's something very and this is I've seen it, especially at Benevolent be having some complicated stuff, man. Like we're talking about biology and chemistry, and it's hard. So, and other domains are even more complicated sometimes, right? Like this can be a very like complicated thing, but you're looking at like the easy part, like the machine, which is it's easy to forget that there's a lot of stuff happening underneath, a lot of science, a lot of really complicated things that could be happening.
That's awesome, dude. Really well put. And so, do you want to jump on to the next? There's another diagram in here that I think is
Yeah.
interesting that they point out,
Yeah.
like
So this
different
is
characteristics.
Yeah, so we've been going over the characteristics of each of these stages, and that's what I'm going to go through now. You notice here that the pipeline consists of these following stages. So for those of you following along, Demetrius is going to be looking at the picture. Maybe you can zoom in just a little bit more.
Yeah, for sure.
Demetrius is going to be highlighting the picture. I'm going to be reading through some of these characteristics. So, all right. The first thing here that you should highlight and that you should notice is that there's a close link between experimentation and production. So you should be able to iteratively try new algorithms. You should be able to do new things, and it should be run as an orchestrated experiment. So like you shouldn't have to do this step and then that step and then this step and then that step to rerun the whole thing. It should be, I'm going to rerun the whole thing altogether. And then the result of that is source code. So you do all this experimentation, you do all your development, and what you produce is, instead of just a model, right, you actually have some code, like depending on what tooling you're using, to produce that model should you need to. So this is very important because you're not producing just a training artifact. You're producing code that could generate that training artifact. Okay, so let's hold on to that. Keep going. Then you have the pipeline continuous integration. So you have the source code, you have your pipeline, right? You build that source code, you run all your tests. Again, going back, thinking with the continuous integration and continuous delivery. But the outputs at this stage now are pipeline components. Okay, so this is where I say it's more Kubeflowy. So for example, but this doesn't only have to apply to Kubeflow. I think this could fit in with other tooling. So you have packages, you have executables, you have your artifacts, and all of this is like the byproduct of that then needs to be deployed into a specific environment. So here's where continuous delivery happens. You deploy those artifacts to your CI stage, right? To your prod environment, your stage environment, your dev environment. And what the output of this stage is now is a deployed pipeline. Okay, so now you've just deployed not just a prediction service, but an entire pipeline. And it has the latest implementation of that model. So you have this automated pipeline, all right? Real quick, we're almost there. Then you have things like automated triggering. So something enables that pipeline to run again. It could be an external trigger, like outliers are happening or concept drift is happening, or it could be you have a new idea and you want to try it. But the output of this stage is going to be a trained model. So once you trigger that pipeline to run again, the byproduct of that, or the output of that pipeline, is going to be a trained model that's going to be pushed to your model registry, right? Yep. So you have your trained model, you have your trained on your latest data, and what's going to happen now is typically like this monitoring, right? You're going to collect statistics on how your model is performing based on the latest live data. And the output of that stage is a trigger to execute the pipeline or to execute a new, yeah, exactly, or to execute a new experiment cycle. So you see how this feeds, it's like a feedback loop.
Yep.
If you notice something in your live environment that's wrong, let's go back to the start. But if you have it automated, it's easier to get back to that endpoint again. Right. Mm-hmm. And that's what I think they're trying to do. And if it's manual, then there's room for error because you have to do this and then do that, and things can go wrong in between. Mm-hmm. But if it's like all one thing, it's more likely to be less error prone. And that's what's one of the nice things about automation, right? Is that it gives you a little bit more predictability and reliability. But if you're automating it in the wrong way, then it could be a problem. So it's very important to be able to just crap an infinite loop of crap. Yeah. But yeah, let's recap the outputs. So
speaking of outputs, because I wanted to ask you about that. Like, I understand the source code, you're experimenting, and then instead of outputting a model here, you're outputting this source code. And I know there have been companies that are trying to attack like this problem of how model source code is not the best for GitHub or whatever, but that's a whole nother topic that we can talk about later. And then you have the pipeline happening and they're outputting packages, or you also said other
things to run. Like so it could be like, an executable is like some like binary that runs. And it could be also like other additional things to make your pipeline work.
And so I'm wondering, do you have like that also stored somewhere? So that
typically, sorry, go ahead.
Yeah, just so that you can go back and you can know how that worked out. Like, I'm just thinking about like the reproducibility aspect of this.
Yeah, absolutely. This would be, for example, if you're using a tool like GitLab. GitLab allows your pipelines to produce artifacts. So it could produce these packages that are compiled, and it would be stored using the source control system that you have. So there's definitely ways to have this reproducible. There, again, I'm not so familiar with some of these other CI/CD tools, but for any of our listeners, would love to hear about how do you reproduce these packages should you need to. Typically, this is done in like the same place where my model code is existing. it's going to be in that same code base, just produced by the pipeline. And if I need to, I can just rerun that pipeline and literally click on it, and it reproduces those packages.
Nice.
And then,
then you output the next stage. You're outputting this pipeline, which is automated, which is basically, if we go back here, you're outputting this whole piece.
The blue one right here.
Yeah.
Data extraction.
Sorry,
exactly.
too big of a circle for you. I was saying you're just automating this whole thing
All
right
of this,
here. This whole piece right here, which is the automated pipeline part, so that you have the data extraction, validation, prep, training, evaluation, and validation again. And so, like when you push that automated pipeline, and now is when you get to the part of the continuous training, which is basically why they wrote this paper, right? That they're introducing this.
It's a big thing, like they really emphasize like retraining. And I know that there's been some feedback in the community about this, and I'm not going to belabor that point, but this is where now you get your fresh data. You have your deployed pipeline. You could run your deployed pipeline on the latest data, and you could do that in a continuous fashion to produce new trained models. And once you have that trained model, you're going to push it to a registry where you could, keep track of that, store that, see that in a nice way. And then the next stage is going to be once you have your trained model in your registry, then you deploy your prediction service. Now there's some service if you have that sort of, if that's how you're serving your model, because there's other ways to serve it. That's what's going to be happening. You have this prediction service, and the output of that is a trigger. So this is interesting because this could look very different. Like this could be a manual thing. The model is doing terrible. We need to update it. We have this sort of automated system where if the scores go below some threshold, trigger retraining. So there's a lot of different. There's a lot of different things that I think you could do at this stage. But the gist of it is that you're having something to start it all over again, and it depends on what your use case is.
And I think a lot of data scientists that I've talked to really fantasize about this idea of just like continuous or like automated retraining. So it's like, oh, my model just gets triggered and then it retrains and it's all good. And we go back to that point you made earlier of like, yeah, that's great, but you also need to be doing this whole part too. Like that's where the data science starts to happen when you go back and you're starting to look at this experimentation that we were talking about up here in this whole section. When you have it out and it's in production, but then you have like, okay, what can I do to better this? How can I make this model better? And then push it out again. So man, this is really clear to me. It's like there's a little circle or like a feedback loop happening here, right? And it's automated.
You have certain tools to make that automated, right? You need something to build all the containers,
something
run
to
all your tests. Exactly. Hopefully you have like a feature store to take care of a lot of the data part. Yep. Some pipelining tool, something to string together these different components. Again, there's lots of great tooling out there available for that.
Metadata store or
the metadata store,
model registry.
Yep. So again, we try to highlight, what they think of it as, but let's close up with the major components of this maturity level, and it's CI and CD. Why don't you start with CI? Because I would love to just recap what we mean by that, unless you want me to take that.
I'll take it. I'll give my best shot.
Do your thing, man.
All right, man. So with the CI, I mean, you see in the figure, it's really like emphasizing that these pipeline components they're tested, the packages are built, the pipeline components are built, tested, and packaged when the new code is committed or pushed to the source code, right? Repository, like a GitHub or even whatever. We all know what those are.
Yeah, there's a bunch. Yeah.
So that's something that is super interesting. How it's like, all right, that is the CI part. How it's like the pipeline and the components, they get built when they get pushed to the to whatever, your GitHub or whatever.
Yeah.
And so then there's also the unit testing for your feature engineering logic. I think that's a part that they mention, which maybe you can explain more, because I don't know if I fully understood that.
So the code or the logic that was used to reproduce those features, if you don't have a feature store that has that logic stored, let's say you have in your own model code base, you have a lot of logic and code to actually take these data from these sources, do what you need to do to it, then that feature engineering logic or that feature generation logic needs to be tested. And the most basic test is a unit test. So there's a single unit of work, maybe it's like a single method or a function that needs to be tested. Then you want to see how all those pieces work together. Then you need to write integration tests, and you maybe want to make sure that there's you understand the relationship between your code base and the APIs that you're depending on to pull that data. Maybe you need some contract tests. So it's just the gist of it is that you just need to write tests for your code.
Yeah,
but just simply put.
And that's what you have that ability you're doing in this stage of the CI.
Yeah, because it runs those tests for you. So like what this typically looks like is, I'm writing my code, do my thing. I'm just, let's say I'm being a lazy programmer that day, right? So I'm there writing my code. I'm not really caring. I push my code, push it to master, but there's a bug in it. But it's okay. If I have CI/CD, all my tests are going to fail. So it won't actually merge into master. So things won't happen unless these tests are passed, right? And that's really, really helpful.
And is that what they're trying to do too with this whole like CI/CD CT? So the idea there is that like a model won't be pushed on accident or with a bug in it because it won't hit the tests.
I think that's definitely something that they are, it sounds like they really care about. And I think that's actually really good too, because you want to fail fast. You want to fail as fast as possible. You want to be able to, know as early as possible when something needs to be fixed. And tests are one of the best ways to do that. They check correctness. Is this how I expect it to be? They test how things work all together. Again, tests are really, really awesome. I think someone asked a question about this in the community around like good testing practices for an MLE or for MLOps. I think those are great questions. Those are the types of things and skills that I think actually make you a better engineer, and they help you do better work because you're finding the problems as fast as possible so you can address them. It's boring, it's not sexy work writing a bunch of tests, but it's helpful and it actually makes a big difference. But the gist here is that you're writing all the tests. You could do something referencing the ML test score. You could do a lot of simple things like testing your data, your feature schema, test if your model converges. So if you're training your model, does it actually converge after an epoch? Make sure that there's no nans or missing values in there. Make sure that you're actually getting the expected artifacts out of your pipeline. Like if you're supposed to be getting a compiled Qflow pipeline and you only see like an empty file or something like that, then maybe that, again, it's some of those basic things and some of those more advanced things that could be happening in this automated way. Typically, you want to, like the things that I like to automate for like the CI are just like, yes, very simple things. Are my features of the data type that I expect? Are they within the range of values that I expect? Is my model loading incorrectly? Like it could be but notice how if you're doing that manually, like, you could, but it's easier to miss that. So if you have it automated, then you always get that every single time you make a change. And not just you, anyone who's contributing to it. So keep in mind that that's why this is even more important when it's automated, is that if you have a lot of people collaborating and making changes all the time, sooner or later, if, there's bound to be conflict if you're not like, having some of these automated checks in place.
Yeah, it's obvious because you may know what to look for better than somebody else, and then they don't know, and it just goes right past them. And it's also a lot easier. Like you said, the lazy programmer, you're going to enjoy that more, just being able to do it that way. So let's talk about the CD part of this.
Yeah, so at this level, your system is continuously delivering new pipeline implementations, so new versions of the pipeline. and you're deploying it to your target environment. So again, that, depending on what your setup is, you want to be able to do that. And this may be even more important if like you have separate environments for different clients, which is something that's not uncommon. Like a benevolent, we have to create a whole new cluster, whole new EKS cluster for a client. And it has its own environment, its own thing, you know. So like again, if it's not just deploying it, it's being able to deploy it where you need it to be. And then yeah, what that does is that delivers a new prediction service of a newly trained model. So what they talk about here is for enabling all of this rapid and reliable continuous delivery, you need a few things. One, you want to make sure that you're verifying the compatibility of the model with the target infrastructure before you deploy your model. So there's actually a couple ways to do this. Like there's some deployment strategies, like a shadow deployment, right? I want to just deploy my model into my target environment and just make sure that it handles the load that I expect it to handle as the last model. Maybe, you know, it's just a simple infrastructure check. Maybe you're using things like feature flags, or maybe you're doing things like a canary deployment. Again, it could be very simple, like testing the infrastructure, or more complicated. But whatever the point is, you still need to verify that what you have works, that it's installed correctly, that you have the right memory, the right compute. If you need a GPU, that's working properly, basic checks like that. Then you could also do things like testing the prediction service. So call the API. Do you get the expected outputs if I give these inputs? Do you get the response that you expect? So there's a lot of things that need to go into there, just making sure that the prediction service is actually running correctly outside of things like, you know, the statistics of the predictions. Nice. Then there's more like, you know, infra stuff, like test the prediction performance. So like the prediction service performance. So maybe you're doing load testing, capturing metrics such as how many queries per second, or model latency. Very important. You know, if you have like a real-time application, you want to know that stuff. You want to know if your model is super slow, how can you speed it up? And then here are some of these latter parts that I think are really important, and they're more sciencey. It's like you're doing validation of the actual data, validation of the models. And that's something that's like a little bit harder to automate, in my opinion. Like it's very hard to like automate some of those checks, especially if you have a complicated domain. But nevertheless, if you're doing continuous delivery, these are things that you should include to make sure that that's reliable. Like if you're automating shit, make sure that you have these checks as well, right? You know, not just these simpler ones, but also ones that validate like the quality of things. And
so
I think,
you're saying like that it's very difficult to automate that, but you should at least have some basic like baseline so that it doesn't fully slip through the cracks or get like forgotten about.
Yeah, it's like kind of what Satish was talking about. It's like just because it's hard doesn't mean you shouldn't do it. And this is sort of the context of a schema. It's like, oh, maybe this doesn't apply, but it's not always an excuse to like not do that. And it's kind of like the same thing here. Like, yeah, it's difficult to validate your model in an automated fashion, but it's not an excuse not to make some, you know, attempts towards that. Again, it may be fruitless depending on your situation, but
something is better than nothing.
Yeah, I think so. Okay, and then these last parts is that your deployments, right? You have either a fully automated deployment, you have a kind of like a semi-automated deployment, or it's manual. Either way, you need to be able to deploy that in a reproducible fashion. So there's a lot of interesting tools that are being created. I know a lot of companies are even creating their own infra teams to make that easier for data scientists. So like if a data scientist wants to spin up a database for whatever reason, it should be super easy to do that without them having to go into Kubernetes. So like there's a lot of interesting tooling happening in this space to make deployment easier, not just for a prediction service, but for the other things that you may need. And deployment is really hard. Like we talked with a lot of people working with Kubeflow, for example, about how hard it is to stand up that entire tooling ecosystem, right? It's just tough. So depending on your situation.
Another one that came through like more recently is which serving platform should I use?
Yeah.
Like should I use KF serving? Should I use
TensorFlow serving? Yeah. Like what do I use? And these are, I don't have good answers to this stuff yet, man. It really, like, it's as always, it depends. You know, like it depends. But yeah, why don't you? I think that's all I have to say about this. And I feel like, you know, this has been the never-ending paper, as we said. So I think we're good to close. So just wanted to close this out, man.
Yeah,
Why don't
man.
you
Let's just
summarize
think
this
about
thing?
what we've talked about so far. It's like we understand that there are different levels, there are different maturity levels, and it doesn't mean that it is bad if you are at the level 0, but there could be things that you can do differently that may make your life easier. And hopefully by going through this and looking at this with us, you can see like, oh, well, maybe I can implement that piece into what I'm doing. And you can try to up your maturity a little more. The other thing is like, it's not just deploying a model and having some kind of API with that model, right? There's so much more that goes into the whole maturity piece. It doesn't
Yeah.
mean like, because I know there's a lot of companies that are just trying to figure out what data do I have? Can I do something with it around machine learning? And then once they do create something, if they do create something, because sometimes that's a total waste of time, but that's another topic. If they do create something and then it's like, okay, now how do I get this out? And they get it out, and then it's like there's so much more to it than just that, right? And
Yeah.
we've
Yeah.
seen that
Absolutely.
there's so many more pieces to this puzzle that you want to have in mind. And one thing that I think is really interesting that someone actually in the Data on Kubernetes community told me is they said like one of the best pieces of advice that they got is start small, like start doing it small and then like build your way up. But we have in our minds that, oh, I'm going to have all of my everything migrated to Kubernetes in 10 months. So I'm going to provision like a bunch of infrastructure for that. But then
Yeah.
it's only like 2 weeks or 1 month into it, you realize, well, this whole migration thing is going really slow and I'm spending a bunch of money on all this infrastructure because I thought everything was going to be over there. So that ties into what we're talking about here, because it's like, just start with what you can, do it on this maturity level 0 and have in mind, like, yeah, let's get to maturity level 1 when we can and maturity level 2 when we can. But like I would look at it as just like a very much like building blocks that you
Yeah.
can try not to form any bad habits as you're
Yeah.
going to the next stage.
Yeah, yeah. There could be an iterative path to this like fully automated scenario, right? Like you can work your way up to that. But you know what? I am open-minded to hear from others that maybe that actually isn't something you should work your way towards.
Yeah.
And I would love to hear why they think that. Personally, I can't really see why that's a bad thing, like to have everything audit if it's done right. But nevertheless, yeah, I think that there is an iterative path to automating things. It's probably always wise to start simple. Very good advice. I also, agree with that because it's almost simpler to add things later on, right? Versus like I have to build everything now.
Yeah.
And usually and I know this because I fall into that error myself, right? Like I want to build a perfect system, man. I just got to be like this, got to be like that. But it's like, maybe we just start with this little thing right here. Get that right. That's working cool. And being okay with that. But yeah, I wonder if part of the problem is like unrealistic expectations about, like how long some of these things take to stand up. And I know that it's very hard to estimate how much time some of these things will take. Nevertheless, I wonder if that plays a role in that. Like, I think you need to understand that a lot of this stuff, if you're doing it on your own, is non-trivial, right? Like, maybe that's even another reason why a lot of people are using these managed services, because it's just hard. You need a lot of expertise. You need a lot of expertise for that.
Exactly. Right on, man. Well, thanks for going over this with me. I've learned a ton, and I appreciate you diving into it and explaining these more simple concepts, because I feel like I understand it much more now. Like I understand the bigger picture. I understand where most people are trying to get to and why I feel like sometimes it can be so daunting, because you look at that diagram or you think about like how my little CI/CD production system is, and it's like, it's got some work, but really, like you said, it's just an iterative process.
Yeah. And to close, we'll try to summarize everything that we learned. I wrote a sentence or not a paragraph for that. So
All right.
here's our best summary. To summarize, implementing machine learning in production, in a production environment, doesn't only mean just deploying your model as an API. Rather, it means deploying the pipeline that you can automate for the retraining and the deployment of new models. Setting up a CI/CD system enables you to automatically test and deploy those new pipeline implementations. And the system lets you cope with rapid changes in your data and your business environment. So you're able to respond to those changing business needs. You don't have to immediately move all of them from one level to the other. Again, like kind of we've been getting at, you can actually gradually implement these things to help improve the automation of your system development and production. So there is an iterative path to maturity level 2. Nevertheless, I hope, I think for me as well, I thought it was helpful to see a high level overview, and me and Demetrius are very interested in seeing other articles like this. So please send them to us if you know it.
Other articles, or if you have anything that you're like, oh man, I have something to say about that. Like, we did it like this. You have some stories, come tell us, and we'd love to talk with you.
Yes, sir.
All right.
So yeah, man, I think that's good on my end. We hope you guys have enjoyed this. Demetrius, always a pleasure.
Adios, senor.
Bye, guys.